Okay, logarithms here, and logarithms, very important. We have a good working knowledge of the rules of logarithms. Here we go. I shall write them down. Logarithms are all about indices, and at some point in this question we're going to be thinking about indices as well. Logarithm of x to the power a equals a times the logarithm of x. Very important rule, that one. And those are our three logarithm rules that we will do well to remember. Okay, to the question. What we have. Logarithm. These work for any base, by the way. I've not put a base in because they work for any base, doesn't matter which. So logarithm base c of 15. Now, since I don't know the logarithm of 15, but I do know 3 and 5, I'm going to think of this 15 as 3 times 5, and I'm going to take this rule here and work backwards through it. And that will give me p, which I've been told is log of 3, and q, which I'm told is log of 5. And that's my first one. And part 2, 25, which I do well to see as 5 squared. And using this rule here, what I will get is 2 times the logarithm of 5. In other words, 2 times, and logarithm of 5 is q. There we go. Those are my answers for my first part of the question. Let me just put those out of the way a minute. And what else have we got? This question now. Important question, this one. We have logarithm base d, 6. Now, we might think this is a change of base, something like this. The best way to deal with this one, in fact, is to remember what a logarithm means, and if you forget, it's worthwhile just thinking of an easy case. Logarithms are about indices, and an expression like this, for example, logarithm powers of 10, base 10 of 100. The logarithm asks what index of 10 gives me 100. The answer is 2. So these two expressions here are equivalent, and we can flip between one or the other. Quite often with things like this thing, it's better to have the index than it is to have the logarithm. Things to do, well, I could use rules of logarithms to help me here. I could sort this out and get, for example, I could say that 2 logarithm d of 6 multiplying both sides by 2, and so logarithm base d of 6 squared equals 1, logarithm to base d of 36 equals 1, so I could do these sort of things. Let me take this expression here, so 10 squared equals 100, and therefore, going back to this one, d to the power 1 equals 36 is the equivalent expression, which tells me d equals 36. If I'd have gone straight in with that idea here, could I have done it? Well, I think I could. D to the power half equals 6 is what it would be saying. And a power of a half is a square root, so I'm saying the square root of d is 6. In other words, squaring both sides, d is 36. So, flipping between logarithm and index expression, and use a common, well-known example if you forget what it is. And there we go, we can flip the expression back to an index and find our answer.